lightning round talk on lightning round talks is 90 seconds. These are all students who are either giving posters or oral presentations here or just want to share their science with you. And they'll have 90 seconds, no visuals to tell you all about themselves, who they are, where they're from, and what they're doing, and why you should come talk to them at the breaks. So with that, we'll just get started at the top and just go ahead and cycle right through rapid fire. Thank you.
Good morning. My name is Lena Heffern. I got my master's degree in nuclear engineering out of the University of New Mexico in Albuquerque. I'm currently working at Lawrence Livermore National Labs in collaboration with Johns Hopkins Applied Physics Labs. We're doing research and development for high purity germanium detectors. So we're developing the high purity germanium gamma ray spectrometer that's currently proposed on the Psyche mission to 16 Psyche, the giant metallic asteroid. The work that I've been doing has been on mechanical design, electrical design, and then of course characterization through neutron activation analysis of these detectors. So what we want to do with the neutron activation analysis is to get a really good idea of the sensitivity of our detectors so that they can be used on various different interplanetary missions. Missions in the past that we worked on include Mercury Messenger, which went to the planet Mercury. A lot of the data from that was incredibly useful. So we hope to continue that work and send our detector to many different planets and small bodies. My poster is number 40. I also give a talk at Lunar GradCon. I can talk about the instrumentation, and I can also talk about the science as well. And I'm currently in the position to apply to PhD programs. Thank you.
Good morning, everyone. My name is William Yu. I'm a PhD student at the University of Southern California in my last year, working on modeling dust grains that and how it's charged and transported around the asteroid. So that was a great introduction for me from Dr. Horaney. So I got my undergraduate at University of Wisconsin in mechanical engineering, and and now I'm working in plasma science. In my last year, so I'm starting to look at prospective job markets. So if you guys have any advice, I'd be happy to hear it.
Hello, my name is Christopher DeMott. I am from the Upper Darby High School Lunar Planetary Club, and we were interested in studying the thickness of basalt in lunar maria. To do this, we used two methods, one using craters that were formed before the mare was formed, and another using craters that were formed after the mare. From this, we were able to create isopac maps of the depth of the basalt, which we hope could later be transferred to show a detailed image of what the surface of the moon looks like beneath the mare. We have a poster, number 46, and we hope to see you there. Thank you.
Good morning. My name is Ariel Deutsch, and I just completed my first year of graduate school. I'm in the Department of Earth, Environmental, and Planetary Sciences at Brown University, where I study with Jim Head. Most of my research is related to the water ice deposits, which have been cold trapped in the permanently shadowed regions at Mercury's poles. And in general, I'm interested in how water ice is introduced into the solar system and then how it manifests on the surfaces of other bodies. I'm also interested in the utilization of these resources as water for astronauts or fuel for rockets. Today at 2:30, I'm going to be giving a talk where I'll be comparing the polar volatile inventories on Mercury with those on the moon. So again, my name is Ariel Deutsch, and I look forward to discussing these themes with you this afternoon. Thank you.
I'm Indu Varadarajan. I'm doing my master's in planetary science at University College London. So as a part of my thesis dissertation, I'm working on mineralogy of lunar far-side basalts, a remote sensing perspective. Why we do this? Because we have been exploring near side using telescopic observations, human and robotic landings, but we don't have any of such information about the lunar far side, and we don't know where meteorites come from. So I'm using Moon Mineralogy Mapper, REM-Cube of Chandrayaan-1 to study the spectral behavior of these far-side lunar basalts. So I'm deriving spectral parameters such as band center, integrated band depth, band area, band strength to study the composition of these basalts. So I gave a talk at Luna GradCon, and I'm here to discuss about my results with anyone at any time here. I'm here till tomorrow. So after my master's, I'm going to DLR to work with Mertis payload of BP Colombo to Mercury this December. Thank you.
Good morning, y'all. My name is Yashwant Pumbla. I'm a grad student at the University of Texas at Austin, and I spent my time there simulating the L-Cross mission. For those of you that may not remember, the L-Cross mission studied the moon in the best way possible by crashing a giant fuel tank into it and trying to see what came up. I'm modeling that impact plume, and I've made a number of updates to it that I think can help us better understand what we observed. I've updated our photo dissociation model to consider photon excess energies and how that impacts the recoil velocity of our product molecules. I've also updated the ice grain sublimation and heating model to consider calculations from Mie scattering theory. From doing that, it seems like pure water ice grains last too long in a vacuum and to fit what was observed, which has two possible implications. One of which is that the water ice was dirty, and the other is that another source of water vapor was formed as a result of the impact. I'll be at poster number 18 if you guys want to talk about that or plumes in general. Thank you very much.
Hello, I'm Keenan Huntstone. I'm an undergraduate at Howard University. I'll be finishing my degree in physics this fall and applying for grad school. And for the past 2 summers, I've had the opportunity to intern at the Goddard Space Flight Center, working for the Dream 2 team, looking at observations from the Apollo Charged Particle Lunar Environment Experiment, which was a machine deployed to the lunar surface during Apollo 14. It has a very pretty unique data set that allows us to examine surrounding plasma environment from the lunar surface. From this, we can look into the lunar surface, its exosphere, and the surrounding plasma environment. Specifically, I look at constraining lunar surface charging on the day side in the tail lobe and plasma sheet regions of the Earth's magnetosphere. And I also looked into previous analysis of this data that reported a lunar day side surface potential of 200 volts positive, which we were curious about. It seems an order of magnitude off from our models. And so if you're at all interested in that, or you'd like to see how Apollo data is still relevant today, I will be at poster 34. Once again, I'm Keenan Huntstone.
Okay, great. We're going to start the transition into our parallel sessions. In this room, we do have, what do we have? We have mission concepts, roadmaps, and perspectives. In the far room, we do have dust, exosphere, and magnetism. And then after the parallel sessions, we will reconvene back in this room for the NASA Town Hall, which will be given by Jim Green remotely and Victoria Friedenson, who is here in person. And then there are a few bits of errata. Quickly, Matthew Sigler and Tony Colapreet, their talks will be switched in the parallel session. So Tony will be giving the last talk in the session. And also one other small bit of errata is that tomorrow morning's talk by Jake Bleacher is not the Global Exploration Roadmap Science White Paper updates like Greg gave yesterday. Instead, he will be talking about the NASA astronaut geological training. So with all that said, we got about 5 minutes for transitions, and we'll see you back in here for the NASA Town Hall. Thank you.